NVIDIA just dropped a monster of a model that's smaller than DeepSeek R1 but still beats it in most tasks. Yup, even with half the size. It can flip between shallow and deep reasoning like a switch, and it runs on just one setup of 8 H100 GPUs. This thing is open source, crazy efficient, and packed with new tricks you'll actually want to try out. Alright, so this new model is built around Meta's older Llama 3.1405B Instruct model, which was already known for pretty robust performance in reasoning and instruction following tasks. The team at NVIDIA did something pretty unique. They used a technique called Neural Architecture Search, or NAS, to pick and choose which parts of Llama's architecture to keep, skip, or fuse together. Some blocks of the network skip attention entirely or compress feed-forward layers, and others fuse multiple feed-forward networks into bigger, more efficient ones. It's all about optimizing memory usage, and the end result is a model that you can run on a single 8 times H100 node, or even on systems rocking NVIDIA's B100 or Hopper architectures with BF16 or FP8 precision. It's honestly impressive that something so large, 253 billion parameters to be exact, can be whipped into shape so that it doesn't break the bank on hardware resources. Now, one of the coolest features is this built-in reasoning on and reasoning off mode. If you're dealing with complex tasks like detailed math or code generation or advanced Q&A, you can switch it to reasoning on, and the model will tap into its deeper chain of thought processes. If you need simpler outputs like short instructions or quick answers, you toggle reasoning off. NVIDIA wants to give developers that fine-grained control. They've even tested the toggling feature on all kinds of tasks. For instance, the model absolutely crushed it on the Math 500 benchmark, going from 80.40% accuracy in reasoning off mode to a whopping 97.00% in reasoning on. Another big improvement is in AIME25, which jumped from 16.67% to 72.5% with reasoning enabled. That's a pretty significant leap, and it shows you how important that special reasoning feature can be. They also tested something called Live Code Bench, which is basically all about generating correct code. The difference was night and day, from 29.03% pass at 1 up to 66.31%. And it's not just code tasks. Another test, GPQA, which is a general question answering challenge, soared from around 56.60% in reasoning off to 76.01% when reasoning on. In side-by-side comparisons with DeepSeek R1, a state-of-the-art mixture of experts model that has a massive 671 billion parameters, the new Nematron Ultra manages to beat it on tasks like GPQA and if-eval instruction following. Even in code generation, it slightly edges out DeepSeek R1. However, the math tests are kind of a mixed bag. Nematron Ultra is not quite at the top on the trickiest math benchmark. For example, on the AIME25 test, it got 72.50%, while DeepSeek R1 hit around 79.8%. And Math 500 is really close between the two, but DeepSeek still narrowly tops it with 97.3% compared to Nematron's 97.00%. It's basically a game of trade-offs still. Considering that Nematron has fewer parameters, it's pretty amazing. Now, NVIDIA has been keen on telling everyone that it's fully open source with commercial licensing. They're releasing it under something called the NVIDIA Open Model License. But it also falls under the Llama 3.1 Community License Agreement since it's built on top of Meta's Llama. Either way, you can actually grab the open weights and even the post-training data on Hugging Face. And yeah, it's ready for commercial use, meaning that if you're a developer who wants to deploy an AI assistant or chatbot or some advanced tool that uses retrieval augmented generation, you can legally do it. NVIDIA is also telling folks to do their own alignment checks and safety evaluations as usual, because these powerful models can sometimes produce outputs you don't expect or might not want. So how exactly did they get to this level of performance? It's not just the architecture search. NVIDIA also ran a multi-phase post-training pipeline. That pipeline started with supervised fine-tuning on tasks like math, code generation, chat, and tool use. Then they did a round of reinforcement learning with something called Group Relative Policy Optimization, Great Poly for short, to hone instruction following. On top of that, they used knowledge distillation for 65 billion tokens, and then continued pre-training on another 88 billion tokens. They name-dropped datasets like FineWeb, BuzzV 1.2, and Dolma, plus a bunch of synthetic data. The synthetic data, by the way, is used to train the model on how to handle these reasoning on and reasoning off modes in real scenarios. NVIDIA says they combined public corpora with machine-generated prompts, so it's basically a big blend. Another interesting detail is that the model's maximum sequence length is up to 128,000 tokens, or 131,072 tokens to be super precise in some references. That's huge, especially when you consider typical contexts used to be more like 4K or 8K tokens. The ability to handle extremely long inputs is especially handy for chatbots that need to remember extended back-and-forth conversations or for analyzing extensive documents. And, let's be real, long context windows can be game changers for folks who want to feed entire sets of text data or lengthy code repositories for debugging and summarization. If you're a developer, hooking into Nematron Ultra is pretty straightforward if you're used to Hugging Face Transformer. NVIDIA suggests version 4.48.3, setting up your pipeline in Python, and controlling the reasoning on and reasoning off modes with a little system prompt that says detailed thinking on or detailed thinking off. For reasoning on, they recommend a temperature of 0.6 and top_P of 0.95, which basically introduces some creativity. For reasoning off, they say try setting it to greedy decoding or temperature equals 0. That means your outputs will be more deterministic. All the code you need is shown in their examples, and they've also put out instructions for using VLLM, so you can serve up an API for your apps. Just set up the server with the model name, trust_remote_code, pick your device map, and you're off to the races. Now, if you're curious about real hardware performance, NVIDIA tested it on 8 H180GB chips in BF16 Precision, or sometimes 4 B100 chips. They even tried FP8 on 4 H180GB cards. So you have multiple ways to run it, but obviously you need some serious GPU horsepower if you're going to do large-scale inference. The main reason it's more economical than some even bigger models is that it uses less memory, thanks to skipping certain attention blocks and compressing feed-forward networks. It's also important to mention that they do vertical compression so that even though the model is 253B, it's not as monstrous in memory usage as you might think. Let's talk about the additional technical stuff. The base model, Llama 3.1405B Instruct, was apparently trained up until 2023, so any knowledge after that might be limited unless it's captured during the post-training data that took place up to 2025. NVIDIA says they started working on this project in November 2024 and continued right up until April 2025. All that time they were refining the architecture, testing the skip attention approach, and doing big knowledge distillation phases. They also highlight something called Quinn, which presumably is a technique or maybe a set of data that improved the model's reasoning. And because they want the process to be transparent, they're releasing the Llama Nematron post-training dataset so people can understand exactly what they fed into this AI. The benchmarks were pretty thorough. I've mentioned a few, but let me run through them the way NVIDIA does. There's Math 500, which saw a leap to 97.00% in reasoning mode. Then AIME 25 soared up to 72.50%. BFCL V2 Live was around 74.10% with reasoning on. There's also something called Live Code Bench 202. 4080120250201, which doubled the if-eval test for instruction following got as high as 89.45% for reasoning on. These numbers are all from multiple runs up to 16 passes to make sure they're consistent. And yeah, that's how NVIDIA gets these final figures. They're pitching it as a general-purpose model for AI agent systems, chatbots, code generation, RAG, retrieval, augmented generation, you name it. It also supports multiple languages: English, German, French, Italian, Portuguese, Hindi, Spanish, and Thai, so it's definitely not just for English use cases. The interesting part is the recommended usage instructions set that system prompt to detailed thinking on or off, and feed your user instructions into the user. They specifically say you shouldn't add extra system prompts because you might confuse the mode toggle. And for folks wanting to do advanced reasoned responses, you basically just rely on the on mode. If you want something quick and factual, you set off. Now, let's talk about the licensing. Because it's open, that means you can check out the code, the weights, and the post-training data. But you do need to respect the NVIDIA Open Model License plus the Llama 3.1 Community License. NVIDIA always emphasizes the importance of building responsibly, so they want teams to do their own testing for bias, safety, and any ethical or compliance issues. They've posted a place where you can report potential security vulnerabilities or AI concerns. The gist is that they want to be transparent, but they also want to make sure people don't misuse this tech. A quick note on the Nematron Ultra naming. Apparently this is part of the Llama Nematron collection. You can also find smaller siblings like Nematron Nano 8BV1 or the bigger Nematron Super 49BV1. It's a whole family. The 253B version is the Ultra, so think of it as that sweet spot between raw horsepower and efficiency. There are references to some academic papers too, like a puzzle-based distillation approach, reward-aware preference optimization, and FFN fusion for large language models. So it's not just marketing hype. There's real technical depth behind how they got these results. Bottom line, NVIDIA's Llama 3.1 Nematron Ultra 253BV1 proves you don't need a trillion parameters to hit top-tier performance. It beats DeepSeek R1 in most tasks, runs smoother, and costs less to deploy. You can grab it now on Hugging Face. It's open source, handles super long inputs, and switches between light and deep reasoning on demand. That's it. Give it a try and see what it can do. Thanks for watching, and I'll catch you in the next one.